Okay, so we changed gears into these series, which means we're adding things up, right? So as we're adding things up, we want to know if it converges or diverges. So if it says converge or diverge, find the sum if convergent, then that's huge. You need to do one of two things. It's either a geometric or it's telescoping. So let's talk about what those look like. So a telescoping is going to be something that looks like this. It's going to be polynomial because the first step is do the partial fraction decomposition, right? And then you make up your S sub n, and then you do the canceling, right? So you've got all your notes of what to do. But in order to do partial fractions, it cannot be numbers to the nth power. Geometric is going to be something like 5 to the negative 2n. It's going to be numbers to the nth powers. That's when it's going to be geometric. So telescoping is going to be polynomial. Things in the denominator, it could have a number up here, right? But numbers to the nth power is going to be geometric. So that's if it says find the sum. There's only two choices. So I'll let you go practice those two, but the hard part is discerning what to do and when, right? Okay, so I'll let you just go practice geometric, numbers to the nth power, telescoping, polynomial kind of things. All right, so far, what else do we have? We've got the integral test, which is really long and ugly, and we're not going to use that often. That's good news, right? So that's one. Two, we've got the p-test. We love the p-test. It's so easy to use. We're going to use it a lot. And then the third thing would be test for divergence. So test for divergence is testing to see if it diverges. Remember, you never, ever, ever say converge by test for divergence. So if you're looking at a sum, so let's just give you an example. So here I have 1 over 1 plus 0.2 to the nth power. And if it just says converge or diverge, it doesn't say find the sum, I would never think of telescoping then. I would think, I do see a number to the nth power, but it's not all to the nth power, so it's not going to be geometric. It's not geometric. Is it, do I want to take the integral of that? I don't want to take the integral of that. Is this p-test? Nope, it's not p-test. All right. So T for D a lot of times comes into play when the other things are not working. So if I put in infinity here, I have a number that's smaller than 1 to the infinity power. So this thing here goes to 0. So I get 1 over 1 plus 0, 1. Okay, what does that mean? This does not equal 0. So therefore, I know this diverges by test for divergence. You need to say the test name when you're doing these series. So test for divergence. So telescoping will always say over here with the sum. I'm going to put this over here that geometric often will come up over here to just be converge. You won't need to necessarily find the sum. All right, so let's look at a couple more. Just a point about this one here. A geometric sum, it could be like 3 to the negative 2n plus 6 to the negative n, like this. So if there's addition inside here, you must split it up to two separate sums. Then find for each of them what the number to the nth power is, right? You need to find the r, and I'm not writing what the n equal 1 to infinity. After you write it down the first time, it's okay not to write it for the rest of the times. You do need to keep in mind what it is, especially when you're writing out the first 3 terms, right? To identify the a and the r. So this is a, and so r must be 1/9. And so a, which is 1/9 over 1 minus r, 1 over 1 minus 1/9, that's the sum for this one. This one here, if I write out the first 3 terms, So this would here be 1/6 is the A, and the R is 1/6 as well. So this is a beautiful answer for this. So if there's addition or subtraction in between, split it up into two separate sums. All right, so let's see. What if I said converge or diverge, C or D? Converge or diverge? That's going to be the question. And it doesn't say find the sum. And then you had something like this. N plus 2 over n to the 4th. All right, so thinking about it, n goes to 1 to infinity. Doesn't look geometric, right? Because it's not numbers to the nth power. Oh, p-test, the test we love the most. Because there's addition here, we do need to split this up as well. So you need to be able to identify. So this would be 1 over n cubed. And this would be 2 over n to the 4th. So they both converge by p-test, right? As long as that p is bigger than 1, and both of them are. So converge plus converge means converge by p-test. Okay, so I want you to start getting used to what you have as tools, because as we move in this week, we're going to be encountering things like... All right, and it could just be a 1 on top here. Doesn't matter. It could be a number. So if you look at this, you cannot use p-test. Cannot use p-test on this because it has to be 1 over n cubed. So this plus 3 stops you. So we'll be learning something else to do with this. So make sure you know when you can use p-test and when you cannot. So integral test is one of the tests that takes so long to use. So when do I want to use integral test? Well, when nothing else is working. Kind of like a T for D. So if I tried the T for D on this, let's just kind of go through the motions. So if I tried taking the limit as n goes to infinity, I would get infinity times infinity in the denominator there. That's 1 over infinity. 1 over infinity is 0. That means nothing. So you can do T for D a lot. You'll get 0. Means nothing. So you go do another test. It's not p-test. It's not geometric. That's when I would think, okay, then I need to go take the integral, and this one would have to start at 2 to be defined. And so then you have to change it to x's and go through the whole process.